Today, we're going to learn about sources of potential difference. Here's a question for you. If all things contain energy, how can potatoes and fruits and tomatoes and apples be used to provide power? Well, to understand, we should know that the movement of charge occurs when a battery establishes a potential difference between its two terminals. What you see here is a potato clock, something that I had when I was a kid. And this potato clock used just 2 potatoes as the batteries to power a small little clock. And all I needed to do to power this clock was put in 2 sets of wires made out of different metals to provide the electricity from this potato battery to power the clock. So, what allowed the potato battery to power a clock? Well, you've heard the phrase voltage. And a physicist like myself, we call voltage a potential difference. And it requires a potential difference between 2 points to provide electrical current. So then your question now probably is, what maintains a potential difference? A separation between charges maintains a potential difference. If we could separate positive charge from negative charge, we could maintain a potential difference. And again, that phrase potential difference, that's just the physicist's way of saying voltage. Now, charge is separated by first doing some work to move electrons from one location in space to another. For this discussion, we're going to be talking about batteries, and these 2 locations in space, we're going to call them electrodes. One electrode will collect or attract, if you will, the positive charge, while the other electrode will attract the negative charge. But in order to separate these charges, work must be done. The separation of charges creates an electric field between the positive and negative charges. As you know, an electric field leaves positive charges and enters negative charges. So the electric field between the electrodes is what causes a difference in potential between those electrodes. And once we have a difference in potential, we have a voltage. So what kind of devices will allow us to maintain a difference in potential between 2 points? Well, EMF devices. First, let me define what we mean by EMF. It's actually an abbreviation for electromotive force. So the EMF of an EMF device is the work per unit charge that the device does in moving positive charge from its low potential terminal to its high potential terminal. Because remember, by themselves, a positive charge will move from high to low potential. But what an EMF device does is it does work so we can take that positive charge and move it from low to high potential. Now, that EMF device is a device that does work on charge carriers to maintain a potential difference between its terminals. But that phrase, EMF, is rather archaic and outdated. It means electromotive force and was adopted before scientists clearly understood the physics behind EMF devices. So it's not a force we are measuring, rather it is a work per unit charge. So one of the most common sources of EMF is a battery. So what provides the energy that batteries require in order to serve as the mechanism to do work to move charges from low to high potential? Well, it's the chemicals in a battery that must supply the necessary energy to perform the required work to allow the movement of positive charge from low potential back to high potential as it completes its journey in a circuit loop. A simple battery can be created by immersing two different metals in an acid. Remember that potato clock? Well, when we inserted two different metals, let's say zinc and copper, into the body of the potato, well, there's some acid in that potato. And the chemical reactions between the metals and the potato caused the molecules to be separated into positive and negative charges called ions. One terminal attracts the positive charge, the positive ions, while the other terminal attracts the negative ions. And then once the ions begin separating at the terminals, a potential difference is established. What's visualized here is a salt battery. So this is a solution of salt water. And in this solution of salt water consists of dissolved sodium chloride, which is salt. The sodium ions are positively charged. The chlorine ions are negatively charged. And when these electrodes are in the saltwater solution, they have different affinities for collecting charges. One electrode collects the negative charge. The other electrode collects the positive sodium charges. And that charge separation establishes a potential difference, which allows that salt water battery to light a small light.